Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Atoms and Molecules. Today let's talk about chemical formulae. Chemical formulae is actually the representation of the compounds or molecules of compounds using the symbols of the elements present in it. For example, in the previous video we learned about calcium oxide, and also we learned about magnesium sulfide, sodium chloride. So these are called a chemical formulae. So in this we know that calcium one atom, oxygen one atom, they combine to form calcium oxide. Magnesium and sulfur in the ratio 1:1 to form magnesium sulfide, and sodium and chloride also 1 each. But when we write other compounds like H2O, so here hydrogen 2 atoms are there, whereas oxygen only 1, total 3 atoms. Whereas another one CaCO3, this is the chemical formula of calcium carbonate. So you know 1 calcium, 1 carbon, 3 oxygen are there. So total 1, 2, 2 plus 3, 5 atoms are there. Or another example I will just tell you, H2SO4. This is actually the chemical formula of sulfuric acid. This is just to understand. So here hydrogen 2 atoms, sulfur 1 atom, oxygen 4 atoms. So 2 plus 1 plus 4, 7 total atoms are present in it. Okay, so we learned that the compounds can be, the molecules can exist in two forms, molecules of compound and molecules of ions. Ions are the charged particles. So here, if it is an ionic compound, like these are all ionic compounds actually. For example, sodium chloride, we know that sodium has a positive sign, that is a cation, and a chlorine is a negative one, that is an anion. And we know that this is a metal and this is non-metal. So whenever there is a metal with a positive charge or metal ion, that is a cation, whenever comes under bonds with a non-metal anion, then only ionic compounds are forming. So whenever we are writing the formula, we don't write ClMn, we always write NaCl. Why? In an ionic compound, we always write the metal first and the non-metal later. So in all these, there are only, in this case, here only 2 atoms, 2 elements are involved. Here also 2 elements are involved. Here also 2 elements are involved. Such compounds are called binary compounds. Now when we are talking about, for example, water or a carbon dioxide, here all 2 non-metals are actually coming together. Such compounds are called molecular compounds or molecules of compounds. So here there also an order is followed, that is actually less electronegative will be first and more electronegativity will be to the right side. But electronegativity is the tendency of an atom to attract the electrons during a bond formation. You will learn about this in higher classes. One more thing to remember here, I told you when we write about calcium oxide, metal first, non-metal second, then magnesium sulfide, there also metal first, non-metal second, sodium chloride, metal first, non-metal second. But here one thing you have to remember, first metal we are using the name as such, calcium, magnesium, sodium. But second one, are we using calcium oxygen or calcium sulfur or calcium chlorine? No, we are using a suffix IDE. So oxygen becomes oxide, sulfur becomes sulfide, chlorine becomes chloride. That way only we use. Okay. Now in some molecular compounds, more than one atom of the same element may exist. In such cases, we have to represent the number using suitable prefixes. Appropriate one we will use. For example, when I am writing carbon and oxygen. So here the second one, how many are there? Only 1 there. So we have to represent it using carbon. Okay, first one we write like that. But second one, how do you write? Mono. Mono means what? 1. So monoxide, carbon monoxide. We don't write carbon oxide. Okay, we write carbon monoxide. Then it is applicable for molecules of compounds. Okay, here it is ionic, so that's why we didn't say calcium monoxide, we didn't say, we just said calcium oxide, because one is metal, one is non-metal. Here 2 are non-metal, so in such cases we are using it. So carbon, can you guess what will come here? How many oxygen atoms are there? 2. So what we use? Dioxide. Here also ide suffix we are using, but we are adding a prefix to show the number of atoms present. Now what is next? I will write PCl3. So you all know what is P? P for phosphorus, Cl for chlorine. So can you try it? Yeah, phosphorus. Then how many chlorine? 3. So which prefix? Trichloride. Right. Now another one. CCl4. C is carbon, so that we can write as such. Now what is the prefix? 4. What is the prefix? Tetra. Then chlorine will become chloride. PCl5. Phosphorus. For 5, what is the prefix? Pentachloride. So this way we have to name the molecular compounds with the number of atoms of the element present in it. If the same non-metals are forming the compounds in different numbers, variable numbers, then their name also will keep changing. For example, NO. NO is a nitrogen monoxide. NO2 will be nitrogen dioxide. But what about N2O? Dinitrogen monoxide. Okay, so like that it keeps varying. But if the first one is hydrogen, for example H2S, so we don't have to say dihydrogen sulfide, we just say hydrogen sulfide. Now let's see H2O. How will you name it? If it is hydrogen, we can just write hydrogen monoxide. But do we say hydrogen monoxide here? We just say the common name water. The same way another one NH3. This is nitrogen trihydride, but we call it as ammonia. So here in such compounds, we never use the chemical name as such. We just use the term that is common names only. Now we are going to learn how to write molecular formula of a compound. Just now we learned about the rules of how to write it or how to name it. First metal, then non-metal, then the name has to be given with a prefix or suffix, whatever it is. But which is the number that is engaging in that reaction? For example, H2O. Why is it 2 and 1? In the previous video we learned why H2O is so. We calculated the ratio by mass and atomic mass, and we found out how they are fusing like this. So now let's see how to write the molecular formula of a compound. For that you should have an understanding of a concept called the valency. About valency you will learn in the next chapter. Actually, overall idea about this can be clear only after learning the next chapter also, because in that chapter we are learning about the structure of atom and the nature of atom, how it is engaging in reactions and all. So that's a base for chemistry. So you have to be very thorough with that, then this will become easy. Even though I wrote many compounds, you may find it very difficult in the beginning, but over a period of time by using, you will naturally get it. No need to worry. Okay, and especially next chapter if you complete, you will get the entire picture of this. But for the time being, I'll just tell you about valency to make you understand how to write a formula. Valency is nothing but the the tendency to make or you give or lose electrons. We learned that the metals and non-metals are engaging in the forming compounds, or two non-metals are engaging in compounds. So how are they doing it? They are forming a bond between them. So for holding each other, they share a pair of electrons. I told you an atom has 3 subatomic particles, because Dalton in the beginning he told that atom cannot be divided further, or it is indivisible. But later we found that atom can be divided, or subatomic particles are there. For example, in the center of the atom there are protons and neutrons. Protons are positively charged, neutrons are neutral or no charge. But there are negatively charged electrons revolving around this. Just like how the planets are revolving around the sun, the same way here also all the electrons are moving in definite orbitals. We call them as shell. So you all have got certain aim or ambitions or goal in your life, right? Some want to become pilots, some want to become doctors, some engineers, or some movie directors or actors, some sports persons, or some good musicians or good dancers, or Our aims are different, our ambitions are different. Some want to become fashion designers, photographers, so many options are there in front of us, right? But you are all trying to become that. That's your ambition. So you do the necessary, or you develop necessary skills, or you attend courses to become that or achieve that. In that, the same way, for electrons also, they have a small ambition. What is their ambition? They all have electrons revolving around in the shells I told. But they all will be happy only when they get 8 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. If 8 electrons are there, electrons are set in life. Means it is well settled. No need to go for reactions. But until they get that 8, they will be roaming around trying to make it 8. Suppose if it has 1 like this, outer, 1 or 2 or 3, they will try to get rid of this, give to someone, get rid of this, so that the previous one, it's completing 8 is easy for them. At the same time, a few will be walking like, maybe they have 6, 7 or 8, they will be frantically looking for someone to give. So in such cases, the give and take is happening. Imagine, sodium is there. Sodium has only 1 in the outermost. So sodium is thinking, if I get rid of that 1, in the previous I will get 8 and happy. At the same way, chlorine is another one. Chlorine has 7 in it. If 1 it gets, it can complete 8. So chlorine will be looking for, can you give me 1, can you give me 1? Then sodium is giving, anybody wants 1, anybody wants 1. Then these two are meeting. Then sodium gives, chlorine takes. So they form a compound called a sodium chloride. Okay. At the same time, there are a few who cannot give, because the number is in such a way, suppose 4 there, but it cannot give completely. Another one also has, but they don't have enough to give or take. So in such cases, what they do? Come, let's share. Okay. So they start sharing. So whenever they are sharing, or whenever they are giving and taking, imagine them holding hands. Okay. So there is an example given in your textbook. We can consider valency as the arms which can join with the other atoms. For example, we are human beings. So how many arms we have? 2 arms. So with the 2 we can hold another person. So if I meet one of you, I am holding hands with you. So we have only 2 hands each. So only 2 pairs of electrons we can share. But then we are walking, or separately. We are not joining, we are walking. We find one octopus. First I am going and binding with octopus, but octopus has got 8 arms. Even though I am holding 2 hands, then 6 hands are free. Then you are also holding, then also only 4. Then you are calling 2 of your friends, come and hold. Then octopus can hold on to 4 human beings with 2 arms each, but whereas we can hold on to only 2 maximum, right? So this is called a valency. In detail how the valency is calculated and all, we will learn next chapter. For the time being, you understand this, and we can refer to this table for the time being for writing the molecular formula. So let's see how to write a molecular formula. So let's start with the first one. Hydrogen chloride is given in NCERT. Hydrogen chloride. So you know hydrogen is there, chlorine is there, right? So from the table we know that hydrogen valency is 1, chlorine also has valency 1. So we will write the valency below that. But now we will be crisscrossing it so that valency of the chlorine will be applicable to hydrogen, valency of hydrogen will be to the chlorine. So it will become H1Cl1. So suppose if both are 1, no need to write. So what is the formula of hydrogen chloride? HCl. We will write another one, hydrogen sulfide. So hydrogen sulfide has which all atoms, elements, that is H and S. Hydrogen atom, what is the valency? 1. Sulfur, what is the valency? 2. Now we have to crisscross. So what do we get? Hydrogen, this 2 will come. Sulfur, this 1 will come. Should I write 1? No need. So what is the formula of hydrogen sulfide? H2S. Then third is a carbon tetrachloride. Carbon, chlorine. Valency of carbon is 4. Valency of chlorine is 1. So how will we write? C is 1, so no need to write 1 here, but Cl is 4. So CCl4, that is carbon tetrachloride. Next we will write magnesium chloride. Magnesium chloride. But here there is a small difference. Here magnesium is a metal chlorine is a non-metal. So they have charged particles. So magnesium will have 2 plus as the valency, whereas chlorine will have 1 minus. Now process is the same, and once you write finally you don't have to mention the charges. So it will become magnesium, it is 1, so you need not write. Chlorine 2, MgCl. 2 is magnesium chloride. Here we don't have to write Mg plus Cl2 minus. Now fifth one we will write aluminium oxide. So aluminium is there, oxygen is there, right? So aluminium valency is 3, oxygen 3 plus because it is a metal. Oxygen is a non-metal with valency 2 minus. So when you crisscross this, how will you write? Al2. Should I write 2 minus? No need. Al2. O3. Sixth one we will write calcium oxide. Calcium oxide. Calcium is 2 plus, oxygen is 2 minus. So here one metal and one non-metal. That's why we are writing metal first, non-metal later. So in this case, what is the answer? Ca2, oxygen also 2. Since both are 2, it will become simplified as 1. So no need to write that. We will write CaO only. There is no need of writing Ca2O2. That will ultimately become CaO. So that's the next one. Let's see aluminium chloride. Aluminium and chlorine. Aluminium, what is the number? 3. Chlorine, what is the number? 1. So how can you write this? Al, no need to write 1. Cl3. Cl3 is a aluminium chloride, but aluminium oxide we wrote Al2Cl3 because oxygen valency is 2. Now we are going to write sodium nitrate. Sodium is Na, nitrate is NO3, nitrogen 1 and oxygen 3 atoms. So Na is a 1 plus, NO3 is 1 minus. So when you are doing crisscross, you will get NaNO3, sodium nitrate. Next we will write calcium hydroxide. Calcium hydroxide means OH. Calcium, what is the valency? 2 plus. OH valency is 1 minus. So when you do this crisscross, you will get calcium, then OH. Then if you write 2 here, then what it happens? Calcium, oxygen, hydrogen 2 it becomes. That is, in this case if I write CaOH2, it is wrong because this 2 is applicable to entire OH group, right? Since it was 1, here we need not write, but here 2 means O also 2, H also 2. So we have to write CaOH in brackets 2 times. So the reading also becomes CaOH twice. Don't say CaOH2, CaOH twice, 2 times. Okay. So now let's see another compound called sodium carbonate. So sodium carbonate, if you write, it has sodium and carbonate. Sodium is a 1 plus, carbonate is 2 minus. So when you crisscross, what will you get? Na2CO3, that is 1. So no need to write. So Na2CO3 is the formula of sodium carbonate. Another one, if you see, we will write ammonium sulfate. Ammonium is NH4. We learn ammonia is NH3. This is ammonium NH4. Sulfate is SO4. So ammonium is a 1 plus, sulfate is 2 minus. So we are going to do the same way. So what will we get? This 2 is applicable to the entire ammonium. So NH4 twice, 2 times. Okay, don't say NH4 2, NH4 twice within brackets, then SO4. That's only 1 time. So ammonium sulfate is NH4 twice SO4. Let's solve these questions given in NCERT. We have to write the formula of sodium oxide. Sodium oxide. So we know there is sodium and oxygen. Sodium is 1 plus, oxygen is 2 minus. So what will you get? Na2O. So sodium oxide is Na2O. Now aluminium chloride. Aluminium is there, chlorine is there. Aluminium valency is 3 plus, chlorine valency is 1 minus. So what will you get? AlCl3. Sodium sulfide. Sodium sulfide 1 plus 2 minus. So what will you get? Na2S. Magnesium hydroxide. Magnesium and hydroxide is OH. Magnesium 2 plus hydroxide 1 minus. So Mg1OH twice. So MgOH twice. Okay, so this is how we find chemical formula. Now the chemical formulae are given. We have to write the name. So here we know this is aluminium, this is sulfate groups, right? So what will you write? Aluminium sulfate. What is this? Calcium chloride. This is potassium sulfate. The potassium nitrate. This calcium carbonate. Okay. Now one more question is there. How many atoms are there in this compound? So H2S, total atom is 2 hydrogen and 1 sulfur. So answer is 3. Here PO4 3 minus. 3 minus is the total charge of that. So P is 1, oxygen is 4. Should we calculate the charge there? No, we have to calculate the number of atoms. So 1 phosphorus and 4 oxygen. So total 5 atoms are there. Now we are going to learn another concept, molecular mass. Molecular mass is nothing but the sum of the mass of all the atoms present in that molecule. We learn every atom has a mass. So when they combine to form a molecule, obviously the molecule also will have a mass, right? So that's what we are going to calculate here. For example, water. Water, you know how 2 atoms of hydrogen and 1 atom of oxygen. So we have to add the mass of all these. So what is the mass of hydrogen? 1 unit. 1 unit is the mass, atomic mass of hydrogen. So 1 unit but 2 are there, plus oxygen is 16U. So total we will get 18U is the molecular mass of water. Ammonia, NH3. Nitrogen is 14U. Plus hydrogen is 1 but 3 are there. So 3 into 1 unit. So how much you will get? 70 unit altogether. Now this is nitric acid, HNO3. Hydrogen is 1 unit plus nitrogen is 14 unit plus oxygen is 16 unit plus 3 are there. Right. So we will get this 48. 48 plus 14. 62, 62 plus 1, 63 units. Now hydrogen, very easy, 1 unit into 2, so 2 unit. Unit means what? Unified mass or atomic mass unit. Chlorine will be, chlorine atom mass is 35.5 into 2, 71U. Carbon dioxide, carbon is 12U plus oxygen 2 molecules of 16U each. So 32 plus 12, 44U. This is CH4. CH4 is methane. So 12U for carbon plus 1U into 4 for hydrogen. So total 16U. C2H6, carbon is 12 into 2 plus hydrogen 1 into 6. So 24 plus 6, 30U. Here CH3, C12 unit plus hydrogen 1 into 3, 3 units plus oxygen 16 units plus 1 more hydrogen 1 unit. So 32 units. So this is how you calculate molecular mass. See, ionic compounds, if you calculate their total mass, then that is called a formula unit mass. The way of calculation is same like a molecular mass, but here it is ionic compound. So we just have to add the sum of the atomic mass of the ions present in it, that elements forming the ions. So for example, here sodium ion and a chloride ion. So here sodium, what is the number? 23 plus chlorine is a 35.5. So what will we get? 58.5 U. U only will write. Okay, then calcium chloride. Calcium is 40U plus chlorine is 35.5 into 2. So 71. 71 plus 40. So 111U. Zinc oxide. Zinc is 65 unit plus oxygen is 16 unit. 81U. Sodium oxide. Sodium is 23 but 2 molecules are there. So, sorry, 2 atoms are there plus oxygen is 16U. So, 46 plus 60, 62U. Potassium carbonate, that is K2, potassium is 39 unit into 2 are there plus carbon is a 12 unit plus oxygen is a 16 unit but into 3. So we can say that 78 unit plus 12 unit plus 48 units. So 90 plus 48, 138 U. This is how we calculate formula unit mass. Next, in the old textbook it is given mole concept, that is deleted portion. So only this much you have to study in this chapter. If you understood all the concepts, please give me a like. Also please share with all your friends, and if you haven't subscribed, please do subscribe to my channel. Thank you for watching Biology My Passion.